Welcome to 118 Part 2, Turtles in Traffic, folks. So we did Part 1. The first half, you learned a lot of if, else, and else ifs, right? That's what we learned. And you did this lesson right here. It was kind of cool. Had a good intro to this. Now, second half, we're going to be applying this. And this becomes kind of a doozy right here. Like, I was messing around with this, but a lot of thinking stuff in here. And there's some things I'm going to teach you to fix, because it doesn't work very well for me. So go down, step 15. My class right here. Paste your final code after doing this. And just, hey, what'd you find challenging and fun doing this activity? That's kind of what I want. So let's begin. Copy and paste this code. So they ask you to do this in VS Code, Visual Studio Code. If you want to do it in that, you can. If you don't, I'm going to do it in Replit. So I'm going to copy. Copy all that code. I'm going to paste it in Replit right here. What does this code do? Ignore this. Actually, it's not what it is. That was take number 1 of this lesson. Oh, someone just showed up to Bridge or class. Please type in chat if you just showed up. All right. So what did it do? I kind of missed the thing. Oh, I wasn't paying attention. Sorry. I just went to the dentist today. Replace a broken bracket. Braces off in 3 weeks. And they did it. And then at lunchtime, I was eating soft rice. And I popped it off again. It's their fault, not my fault. So you saw these things shooting out. Now, there's a few things that are wrong here. So let's see what the lesson asks us to do. Review the code so you understand how the turtle objects are created and placed on the screen. Add comments in the blank lines for the for loop, depending on what the code is doing. If necessary, run your program in VS Code. So I guess run it again. And so here's the thing. This is supposed to do something else. Like, stuff's going on, but the screen's not big enough. In fact, you go full screen, you can kind of see it right here. But here's what I want you to do, and this is important. I got this from the teacher forums. One of your teachers told the answer. What I want you to do is there's 2 lines you're going to have to paste, because we got to make this canvas bigger or fit everything. It's sized probably right if you do VS Code, but if you're not, it's not going to work. So I want you to go in like step 5 here. I want you to paste these 2 lines right here. Paste 5 and 6, right? Now, you can kind of see better of what's going on, right? Now, in 5 and 6, they actually say, oh, you can delete this line right here, the turtle screen. Sure, you can. I don't care, though. It doesn't matter. Looks like it works anyway, so probably weird to have it twice, but make sure you have these. I think you have to put this in the top, and then you're changing the screen size to kind of squeeze it all in, all right? So make sure you do all that. All right. Now, you saw what happens right there. We have a bunch of these turtles pop up. Last activity. Oh, I switched. So it says, you will apply knowledge of conditionals to iteration to a turtle program. We have modified the code from traversing turtles from activity 116. But it has 2 lists of turtles. One that places turtles on the left and one that places turtles on the top. Activity 116 was actually about buggy code and drawing a spider, drawing a ladybug. It had nothing to do. They meant activity 117. 117, folks. But same idea. We just drew a bunch of turtles, right? Let's go back to 118. Scrolling down again. So step 15. Review the code and let's try to understand it. Comments in. So I'll put some of my comments in, but you should comment some more. Put this in here. I'm actually going to put a comment and explain what this does. I'll say, so in case I come back to this, these lines resize. So I'll go up and replicate or whatever you're using. All right, so hey, what is it doing? So the goal is to move turtles horizontally and vertically across the screen. Okay, so horizontally is left and right. vertically is up and down, right? You might just want to make a note of that. Gonna make a note. Horizontal is up and is left and right. Left, right. Vertical is up, down. Hey, I'm not just going to assume that you know that all the time. So we're just going to horizontal, like horizon, left and right. How I think of it. So create 2 empty lists of turtles, adding to them later. So we have horizontal turtles and vertical turtles. Empty lists at the start, right? No elements in the. And then here, use interesting shapes and colors. So one thing about turtle shapes is we have the 6 standards turtle shapes. I've listed them in the list of Python commands. Where we learn about shapes, I think was in early on. I think it was 113. Oh, there's my colors. Yeah, we learned the shapes of the circles are these colors right here. Square, arrow, circle, turtle, triangle, and classic shapes. You have, and all 4 are used here, or all 6. Now we have the horizontal and vertical colors. The different colors that we're probably using. This is very similar to what we did last time. We had shapes in just 1 color, but now we have 2 colors. For horizontal colors, left and right, and vertical colors. Cool. Lime's a color, indigo's a color, dark red, dark blue. Cool. Now we have this thing called T-lock. Like, what is T-lock? So I don't know, but first I'm going to try to guess what this is. So what is this? I'm going to go question mark. I don't know what it's used for. So let's just assume I don't know right now because it just says T-lock. Now, one thing, if I say T, what does T usually stand for? Or T is sometimes time, or maybe it's turtle. We're dealing with turtles. But those are both things that I would kind of assume, time or turtles. All right. Now lock, what is lock? Lock's usually location. So maybe this is the turtle location. I don't know. Lock is sometimes short for location. I'm going to guess maybe it has to do with the turtle location, but let's find out. We got this big for loop. Now, if you're looking at this big picture, we got H of T doing stuff and V of T doing stuff, horizontal and vertical. This code looks very similar to what we did last lesson by placing the turtles. So H of T, I'm making a new turtle with the shape of S. So for every S in the turtle shape, so it starts with arrow. And then it's going to say append that to that new turtle to this horizontal turtles list. And then it lifts the pen up so it doesn't draw. Okay. Now it creates a new color and it pops off the last thing on the horizontal colors list. So gold will be first. And then it sets the fill for the turtle to new color. That's like inside the turtle. And then it does a go to -350, comma T-lock. So this ends up being T-lock is the, let's see, the Y coordinate of horizontal turtles. Cool. -350. That means X is going to be like way over here to the left. And so that's why we need to make this bigger because this is way over here. And then sets the heading to 0. I want to make a comment saying what is 0 if you're talking about your unit circle. 0 degrees is to the right side. So boom, right here. Okay, so you got your whole circle. 0 would be on the right. Set it to go right. 0 degrees. All right, so horizontal turtles do that. Now, you can put some better descriptions of what it's doing in comments yourself. But I'm just making a few things. You should do some more. Vertical turtles, same thing, VT, but on the same patterns, popping the last color on the vertical colors. What is that list? And then go to. Notice the go to is different. T-lock is a negative X value here. So T-lock, I'm going to say it's kind of like, is the X coordinate. It's kind of like negative the x-coordinate, right? Is the negative, but opposite. Maybe I'll say, but it's the opposite. So if it was T-lock was 50, it'd be negative 50. So that means it's going to put them at the left-hand side. You're going to start at the left-hand side and go from there. Okay. So, okay, cool. And then we're going to set this heading to 270 degrees. Now, 270 on a unit circle. So you're right here, 0. 180 would be here. 270 is at the bottom. So set it to go down. And then it adds 50 pixels every time. So think about it, it's shifting a little bit, 50 for each new one created. So that's kind of, let's watch this list again. You might see that code. So after you do all this to create them, come on. Stop it. Did too much too fast. Okay. Notice it's like, duh, duh, so it starts. Yeah. So boom, boom. So these are the horizontal ones. They start on this side and they're going to go to the right. And it starts up here, but then notice the T-lock is going up 50 every time. Boom, 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 boom. And notice on these ones, we start over here and it's going to the left 50 every time. Boom. Oh. Okay, so it's creating all these. It starts off. You can put more comments explaining what it's doing. Go ahead and do that. The idea is we initialize everything right here. It's kind of setting the initial location of these turtles. Okay. The goal is to move, so now that I've kind of commented that, now here's where the challenge is. I did the first take of this video, got about to this part, and then I got mad. I got busy. I had to read. This is all new. Your goal is to move the turtle objects across the screen horizontally or down the screen vertically and stop them if they collide. Read through the next 5 steps and write some pseudocode planning how to accomplish this goal. Then begin writing your code. Okay. Process. So I got to make them move. And then I got to make them collide. Detect if they collide. So process all your turtles inside the while steps is less than 50. Loop. Okay, so we're going to use this loop. Using nested loops, each turtle object takes 50 steps, either across the screen or down the screen. Okay. To detect collisions, you need to know if turtle's XY position on the screen. You'll find the following methods useful. Oh, X coordinate and Y coordinate. Are those new? Nope, we did those before in 1.1. Okay, I thought so. To detect collisions, you need to determine when turtles get too close to each other. In a coordinate system, if positive and negative values, you need to get the absolute value of the distance between the two turtles. Using a new method, ABS, to calculate the distance between turtles' X and Y coordinates. For example, statement ABS x1 minus x2 determines the distance between them. Wow! This is getting crazy. I'm going to do some annotation. So, no, absolute value, if you go 5 minus 3, absolute value, that's going to be absolute value of 2, which is just 2. But if you did absolute value of 3 minus 5, that becomes absolute value of negative 2, which is also equal to 2, right? So it's the difference, but it's always going to be a positive number. So that's the idea of what absolute values do, if you don't remember. We got ABS. ABS does that. If both distances are too close, there is a condition. If both distances are too close, there is a collision. A good distance for turtles getting too close is about 20 pixels. Please note the exact value varies depending on the shape of the turtle. You can ignore that detail for this activity. Collision does occur, stop moving the turtles that have collided. To do this, you can remove a collided turtle from the list. Recall the pop method removes the last element. Python provides another way to remove an element. Remove method searches for an element on a list and then removes it. Provide this element you want to be removed as a parameter of the method. For example, if you have a list of turtles, you can remove a turtle from the list with remove my turtle. Like, Project Lead the Way just turned this lesson up to 11. That's a lot of work to do. It's kind of insane how challenging this is versus everything we've done so far. At least the way I see this. Like, oh, hey, here's a new thing, remove, you just have to use. Oh, here's a second new thing, absolute value. You know, okay, well, let's add these to my list. Abs. I'm going to go dot abs. Wait, it's just abs. It's not a dot. Second. Abs. And then inside will be num. Okay, what does it do? Find the... Okay, I'm going to say it returns absolute value of the number or expression inside. So abs of 5 equal to 5. Abs of negative 5 equal 5. And you can do abs of like 8 minus 13 also equals 5. So I just want to show that you can do math inside. That's my examples. Okay, so in case we need to know that, 118. Cool. And let's do another one. That anymore. And we learned about remove. So let's do remove. It's going to be dot remove. Move element. Removes. This should remove the list. Now, I'm not exactly sure what that looks like. They give an example of remove my turtle. What if you have like multiple? Okay, use the hints necessary. Nah. Okay, so here's the thing. They say, hey, do this in pseudocode, and that's an idea. I'm going to do some notes. So things that I'm going to do kind of one step at a time. So what are the things I need to do? Okay, so I'm going to make a list right here. I need to get the turtles moving. So the first thing I want to do is just make them move. All right. And then what's the next thing I'm going to do? Oh, I put this on my screen. That's right. We can see it when I keep switching. Oh, that's cool. Okay, so the next thing I want to do, I want to get the turtles moving up and down. And how does it check every other turtle? Okay. Check if each turtle. So you really want to now, okay, we got them moving. Let's just get that done first, all right? Let's not worry about trying to figure this all out first. I don't know what this looks like. So I want to take 50 steps. How many steps does it move forward every time it takes a step? Like how many pixels? I don't know. Well, what we should have here is we should have a loop. So while steps is less than 50, so my first thing I want to do is I want to just move everything forward. Let's move the horizontal ones forward first. So I'm going to take all those horizontal turtles. Or, you know, I'm going to do this. For T and horizontal, I'll follow their. So we can do something in the list. For T in the list, I'm going to make T my variable. Why not? Just a letter. Easier. So for, that's like each turtle. So for each turtle in this list, what do I want it to do? I want it to go forward 10 steps, right? So I want to go T dot forward. There we go, 10 steps. All right. And then it's going to do this 50 times. 500, isn't that a lot? Wait, why does it not like this? Not like this. Is that a real problem, or is just unindent does not match any outer indentation level? What? Is forward the wrong command? No. Command. Oh, maybe. I have an issue with that. That? No. What's I don't get where pause. Hold on. All right. I just had to delete and write it again. I must have had some weird character. Really annoying. See what it does after creating all these. Okay, cool. It works. It went forward. Hey. Now maybe you want to make it slower. I don't know. Cool. Okay, I probably need to make it go more than that. So let's make it, I don't know, 8. I'll make it something weird. I don't care. All right. So I made those go forward. Now I want to do this for T in vertical turtles. Okay, verticals are going to move forward. Sure. All right. I got them moving. That's all I care about for now. I really wanted to get them moving. So, check. I can take this, cross it off. All right, so I got it moving. It's a key thing right there. Now, I got to do the other part where we want to detect collisions. So when it said we have a nested loop, we had to have that. We're nested loops now. That's a while loop and a for loop. They're both loops. They're nested. We're good. Now, I want to detect if they're touching. So, okay, there's a lot of different ways to do this. So they're touching if this XY position is close enough, right? Let's say within 20 pixels. Fine, we'll follow their laws right here. 20 pixels. Okay. So you want to stop. Explain this in words. And you say like, oh, I want to stop the turtle if it's too close. So let's the pseudocode. I want to stop the turtle if it is too close to another turtle. Right? That's what you want to do. Now, keywords I've used in there is if. So, and then, okay, if it's too close, when two turtles are too close, stop them. Whoever just joined, make sure you type in chat so I can mark you here. I kind of want to stop them, right? So how am I going to do that? So this is where it gets tricky and spoilery. Gosh, this is tough, huh? Well, you know, try it on your own before you look at things here. And I'm going to look at the hints too eventually. I want to see what they give you. But here's my hints. Because we have to have kind of like a systematic process for this. Let's say the way you could do this, I can't just, is, hey, when the turtles are too close, right? So we're going to have to loop through every turtle again. So we're going to have to check each turtle again. Ah. I can actually, okay. So here's the thing. For each turtle, let's say each horizontal turtle, you got to compare it to each vertical turtle, right? Horizontals you don't need to compare against each other, and verticals you don't need to compare against each other. But every horizontal to a vertical and vertical to a horizontal. One way we can do this is loop through the entire, yeah, you are early. We can loop through the entire loop of horizontal turtles, but inside those horizontal turtles, we're going to have to loop through all the vertical turtles. So this is a nested thing. This is like the key discovery or aha moment here. So I'm going to say I'm going to call this HT in horizontal turtles, and for VT in vertical turtles. Actually, I don't like using the same thing as we used here. That's why I use T. Or I'm just going to say H and V. I just don't like using the same variable. It's okay, but it might get confusing if I'm looking at this later. That's why I'm avoiding that. Now they're not being used for the same things, but it's weird to have the same variable name, but then use them for different things. Yeah. And maybe you want a longer variable, so you could name it something else. I don't care. So what I want to do, and so you're going to go inside. I want to say let's go check the distance between. So I want to do X distance. I'm just going to say that's the absolute value of the h dot x coordinate. Is that what it's called, right? X core with one O. Why did it let me do that with 2? That was, minus h v dot x core. So this is where you're going to be using that. I want to eventually find the x distance between. So I call it the x distance because that's the x distance between the two. Call it whatever you want. I'm going to call it the y distance. Y dist. Absolute value of h dot y core minus v dot y core. Okay. So I got those two. Now I want to say, if it's too close, this is where there's got to be an if statement. See guys how I said that in my pseudocode right here? Now, you probably could do better pseudocode than I did. But if they're too close, then stop them. So if x distance, I'm going to say, oh, I don't like parentheses. X distance, say it's less than 20. That means that distance is less than 20. Now, and then we have to check the y distance. Now, those of you might know, you can use something called and. You might know this. We haven't done this in class, but you can do and it'll check both of those. And that would be the way that I would do this. But since you haven't learned that yet, the way you might do this, you would say if the x distance is less than 20, you would have a nested f in here. A nested if. So it's checking out both. And what we want to do, if both those are less than 20, I'm going to put a comment, stop both turtles. So how do I stop it? So what I could do is remove them from the list. And how do I do remove? I learned a command just now. Project Lead the Way is like, oh, hey, you might need to know how to use remove some random item from the list. You got to use dot remove. No examples. Really? Like, I don't know. If I'm one of you students trying to learn this Python stuff, I don't get an example of how remove works. Like, we did such great examples of how if works. Really good lesson. Now, you don't have examples of how remove works? Then you have to look up online. Come on. Unless your teacher can do it. Man, distance learning makes that hard. That's why I'm here right here. No example. Such a good job with the stuff before. Okay, that's why I'm here. So what you want to do to remove from the list. Now, my challenge here is how do you use remove? I'm pretty sure. Okay, so I'm just going to show you how to use remove. I'm pretty sure you have to go horizontal turtles dot remove and then h, and vertical turtles dot remove v. I believe. Oh, you know what's that's cool. It did that pop up. It says removes the first occurrence of what? Removes the first occurrence of the value. Oh, that's cool. I didn't know it works that way. So like, what if there were multiple turtles of the same number, of the same type? Like, how would it behave? So it just does the first one, starting probably from the left of the list going to the right. But I think that's how it works. Now, you at home might have said, oh, maybe you just type, and this is why I'm kind of frustrated. It's not just, oh, remove H. Because remove from what? So we're removing it from the list. This thing, this first part before the dot. So this remove is kind of like a function within function that you can use. I think they call it functions. They call it methods in here. I forgot if we call it functions or methods. Maybe methods is a Java thing. So remove removes, and this is the list. So this is the thing you're removing it from, and this is like this removes the functions, or think of them as the verbs that you can do to a list. You can remove something from a list. Now, if you didn't have good directions, you might go, oh, h.remove. That's horizontal. I don't like this without examples. Okay, well, there you go. I think that should work. Let's try it. And then removing it from the list is supposed to stop them. Why do I know that? Because it said, if you to do this, you can remove a collided turtle from the list. So it told me that. So let's see what it does. I have no idea. Can't wait to see. Oh, so good. You know, it's kind of cool. Run that again. Watch it again. Watch it towards the end. It speeds up towards the end because it doesn't have to loop through everything, right? Because other things are stopped. The lists get smaller. What if you made the distance okay. Yeah, notice like some are getting kind of close. Like it said, some of the sprites are smaller than others, or turtles. So they might not actually touch like these ones. We're not worried about that right now. But there you go. As soon as they hit, they collide close enough, it's stopping. Kind of tough. Let's see. For each horizontal turtle, for each vertical turtle, that's what we did, folks. I did that 4, 4. Move each turtle forward. Oh, I did mine differently. I just did this first. Check for a collision if they collided. This is where we check for collision. Turn both turtles gray. What? I'm not turning them gray. Stopping them. And remove them from the list to stop them from moving. Oh, wow. So I love this. You know, I think I just spoilered this for you, but literally everything is right here. And they did it differently. So they did forward 3 pixels at a time. I said 8, whatever. 4, 4. Okay, they don't show you exactly how to do it, but okay, if you want to do this, you can make it gray. I'm not doing it. You can put those gray things in there if you want to. Notice how they switched it to removed HD. And then, so they did this. I broke it up and said the distance and then they like this, but you could have just pasted this code into there. That'd have worked fine. You guys are showing up late. Say something. Oh, I guess I can close. All right, back to work. So, hey, I did it differently. You can do it their way. It's fine. It's your turn. Just did that. You can make improvements to your Turtles in Traffic program to make it more interesting. For example, you can vary the speed of the turtles and/or you can change what happens when they collide. You may choose to implement all the improvements described in the next 2 steps or only some of them. Check with your teacher to see if any are required. Is your teacher me? Sure, play around with things. You should comment your code, folks. If you're just copying from me, I kind of expect you to comment the code a little better and explain what's going on. You don't comment anything. Comment more than I do. Just leaving out the comments. That's for you to tell me what's going on. That shows me that you're trying. Or you just have unique code. That works too. Make improvements. So make faster and slower turtles. Make the turtles speed up as they move. Did they get too fast? Slow them down again. Speed up turtles. They cover ground faster. Change the code so they do not go off screen. Change the shape and color when the turtles collide. Delete one of your shapes in your list and collision shape. Color to indicate collision. Got to recover from a collision. Make the turtles back up a bit, then continue on. Oh, like if they collide, they start moving backwards instead of forwards now, huh? Oh, that'd be cool. Okay. So, let's do it this way. I'm going to stop this for right. I'm going to do another advanced part 2, the second part of part 2 tomorrow, where I just start messing with the turtles a bunch. Try to do weird things. But why don't you try some of those at home? We'll do this more later. Bye-bye.